Hello everyone, this is a video lecture for Algebra 1314. We're going through 9.2 right now. So you don't need any of this. I mean, we're using Desmos, but this is actually pretty important. The reason for 9.2 is I would like to call it weird answers. And so sometimes we get weird answers like this one here. That one's not weird because you see how we got the ones and the zeros all right here? That makes it a normal, regular, or usual. Okay, you would call that like one solution. That's what we're looking for. This makes us happy. We just get our answers and we're done. Very simple, and that's how it's been all through 9.1. But 9.2, we're going to have these odd answers, I guess you can say. So in this particular case, we're going to have a 1 here. Desmos always gives you a 1. And so if you've got zeros and then a 1, that's not good. This is called inconsistent. In have to spell? What are you talking about? Inconsistent, no solution. That's it. You're done. You just literally say no solution. You walk away. Okay, so if you have all zeros and then a 1 right there. If you have all zeros and a 0, like everything's a 0, so this is called a dependent solution, and then that's basically infinite answers, infinite solutions. But previously, when we have infinite solutions back in chapter 8, you would just click it and move on. But here we got to do a little bit more math. Yes, that 4-letter word. So that more looks like nath. Let's do it right. Yay. Okay. And I'll show you whenever we get there. So we're looking for the bottom row if it's zeros and then a 1 or if it's zeros and then a 0. Okay? Here we go. Desmos. Every single time, Desmos, Desmos, Desmos. If you want to like remind yourself and say, look, I'm using Desmos and I'm going to do the RREF of A. That's great. This is a 3x4 size, which is very typical. Here we go. And I'm basically just going to do this with you like 12 times, and then we're done. So, yeah. Okay. Notice that here we got zeros and then a 1. No solution. 0, 0, 0, 1. No solution. I don't even care what the other numbers are. You're done. That was it. It's not too bad. Let's do it again. 3x4. Oh, whoa, no. I feel like even though it's easy, I still mess up typing, and yet I still feel kind of bored by it a little bit. I think I'm going to have to tell you all a story here soon as I'm doing all this. So notice that we got the one solution answer. I want that to look better. One solution, right? It's the usual regular thing. And then so my answers are right here, and there's nothing else to do. We're done. So -2, so -2, 5, and then a -3. There it is. That was easy, right? So that's my math lab. You're done. Cool. So I promised you a story. It's a story about this problem right here. Yeah. I don't know. I probably told it in the other video lectures. This is a 4x5. I had a student one time that went through my class, sat in the back, very quiet, didn't really say much, and anything at all, honestly. Got a 100 on every homework, got a 100 on every quiz, got a 100 on every exam, except for the final exam, this question he got wrong. I'll finish the story in a second. So you can see that we got the usual. I'm leaving the story hanging on purpose. I'll explain why. 0, 2, -1, 1. There's my answer. Right, I got my 4 boxes, and here we go. 0, 2, -1, 1. There it is. You're done. Now that's your answer for my math lab. I mean, what else are you supposed to say? Yay! So why did that student get this problem wrong out of all the problems? Why? It's because he said W's. Gosh, man, that should go right there. And so he basically put this answer right here and then shifted them all down one. That was it. And so he had all these same numbers. They were just in a different order. Do you think I gave him some partial credit on that one on the exam? Yeah, I did. It wouldn't have mattered, though. He made 100. So anyways, these little things like that. So leave it alone. I know that's weird, but X, Y, Z, W, that's how they want it this time. That's how we're going to give it to them. Just leave it alone. There's my story. Look, I don't get to tell many stories here. Because we're always doing that math stuff instead, huh? That's fine. 1, 3, -2, 6. Okay. So yeah, and of course we're going to want fractions if it's possible. Okay. This one's different, and we got to sit down and talk about it for a minute. Because you can see that the bottom row is all zeros, which means infinite solutions. Okay? But we can't just click that and move on. We have to actually do more. So right here is the infinite solutions. I'll just put sol. Infinite solutions. And so now we have to do a little bit more math. And how this works is that I have to go back and say this is x, y, z equals a number. And so I'm going to rewrite it now. I got 1x, I got 2 z's is equal to 14. And then I got a 1y minus 4/3 z's is equal to -8/3. So these are my two equations. The bottom row, if you want to know, it's 0 plus 0 plus 0 equals 0, which is just true, I guess. The no solution ones, it's trying to say like 0 equals 1, which doesn't make sense. Anyways, to get our answer, we still need to solve for x and y at least. So we're going to move the z over to the other side, like subtract and then add it, that kind of thing. So x is equal to 14 minus 2z, and then my y would be equal to that -8/3 plus 4/3 z. And then if they have a z equals, it's just z equals z. Just like I'm saying 0 equals 0, I'm saying z equals z. It's just kind of the way they want it, okay? So here's one box, here's another box. They don't normally have a box for that guy. You just kind of leave them alone. So there it is. Those are your answers. I know that's kind of weird, but that's the weird answers, right? Aren't we doing weird answers right here? See? So that's how you do that problem. Let's do it again. I think the next one's going to be very similar. They want to drill this one into you particularly because it is a little different than the other ones. It's the hardest type. Still not too hard. It's just it takes a whole minute. RREF, and there you go. So again, you can see all zeros in the bottom. Therefore, I've got x minus 4z is equal to -2. And then I have a y minus 3z is equal to -6. So let me show you once again without the fractions. This makes it easier. I actually just move these guys over to the other side. When I do that, I'm adding them to the other side. So x is equal to -2, now plus 4z. For my y, it's the -6 plus 3z. And again, z equals z, but they don't really care about that. So those are your answers. That was it. In a way, like once you're looking at your answers here, you got your answers. You just take these and change the sign and move it over. That's it. Change the sign, put a z on it. You're done. Okay, last one. This size is different. This is a 2x4 because it doesn't have a third row. And notice that the order is all kind of weird as well. So this is a 2x4. Just be careful about it. There's 0 x's. And what this is assuming is that the bottom row is all zeros. So this is going to be that dependent infinite solutions. Again, just imagine that this is the same as what we had just a second ago. Same kind of thing. So x plus 17z is equal to 5. I got y minus 3z is equal to 1. I move them over, and I get the answer 5 minus 17z. Y is equal to 1 plus 3z. There's your answers. And then again, z equals z in case somebody asks. Okay, cool. So I hope that you're seeing the patterns. The patterns are important. You can just move them over. You don't even have to write anything down. You can just look at it and say, oh yeah, just move them over, put a z on it. I get it. It's totally fine. Okay, this is the last one because, again, if you go back to 9.1, I already did these two problems in 9.1 because they're 9.1 questions. So we did that already. This is the last one in 9.2 because it's going to be involving those dependent solutions and stuff like that. This has got to be one of the hardest pictures to see, and especially in my math lab, you can't blow it up, you can't look at it very well. The cars are driving on the wrong side of the road, all kind of weird stuff. So you have to see that the arrows are going in and out in these fashions because they are one-way streets. And so like this guy here, we're going this way, here we're going up, this one's going down, and this one's going this way again. Okay, so you have to kind of see that. Looking at the cars, it doesn't always make sense. So I'm sorry. Also, this is W, X, Y, and Z. Okay, so how this problem works is we're going to do intersections for each one, and each intersection has an equation, in equals out, for each intersection. And I almost want to use a different color so that you understand what I mean by intersection. Ooh, nice green. So intersection means this neighborhood. Okay, this is the intersection right here, but then I need all the numbers that are nearby it, attached to it. This 50 has nothing to do with intersection number 1, okay? These are connected directly to intersection number 1, as well as the W and the Z, but that's it. You start going into the next intersection, it'll be over here, okay? You have to keep that in mind. Please don't start adding up all these other numbers that don't belong there, okay? So, it says set up a system of equations. So basically, intersection number 1, in equals out. Going into this intersection right here in the center, going in, I have the 180 and the 200. So 180 and the 200. And then going out would be the W and the Z. Okay, so in equals out. Intersection number 2. So we're looking right here now. Going into it would be the W and the X. Going out of it would be the 400 and the 200. Intersection 3, right here. So going in is a Y and a 200. Going out would be the X and the 30. Intersection 4, we got Z coming in and 100. Going out is a Y and a 50. Awesome. So it's all kind of messy, honestly. We need to clean this thing up and put it in the right order. This is going to be a 4x5, by the way. And we're going to have W, X, Y, Z equals a number. So here we go. Using these as my positives, I got 1, 1, 0, 0, and it equals 380. Here I got a W and an X. Oh, I messed up. This is supposed to be a Z right there. Well, I mean, I do that, don't I? Okay, there we go. Sorry. 1, 0, 0, 1. Z's. This has 1, 1, 0, 0 equals 600. I'm going to move the Y over so that it might have a positive X and a negative Y. I'm going to move this 30 over that way to make this equal to 170. And then finally, I'm going to move the Z over and the 50. So I got 0, 0, 1, negative 150, like that. All right, awesome. So now we got the matrix set up. What we're going to do is RREF to get our answers. Unfortunately, this is not going to be giving you something much nicer. It's going to be a little bit better, but not by much. I also have a story with this problem, but I don't feel like doing it. It would just waste your time. So I might say it in another video if you're like super interested. I probably do. I say the same stories all the time. I guess that's kind of like being a teacher, you know? You just have like these set of stories that just keep happening because there's always new faces. Okay. So you can see the bottom is all zeros, so that's dependent, infinite solutions, that kind of thing. And so as you can see, they don't have a z equals here because they have to give it to us in order to get like the right answers. So how this works is I'm going to rewrite my equations. Again, this is w, x, y, z equals a number. Here we go. I got w, and I'm going to move the z's over automatically, is equal to 380 minus z. I got x is equal to 220 plus z. I got y is equal to 50 plus z, and I got z equals z. So with these equations, I now plug in the 50 to get my real answers. So 380 minus 50 is 330. Oops. Awesome. I got 220 plus 50 is 270. And then here we got 50 plus another 50 is 100. And there you go. That was it. And we're done with chapter 9. That was it. Because again, we did this problem already. And then we move on to chapter 11. So we're done. That was it. Thank you very much, guys. Have a great day.